Math 3, Unit 8, Section 4. We're going to start by talking about normal distribution. So normal distribution, usually you guys have heard of bell curves? No? Okay. You're going to hear about them today. All right, so in 8.2 you learned something about the shapes involved with the distribution of data. This section of the unit covers normal distribution and the properties associated with the normal distribution. One item that we need to look at is that there's different types of normal distribution created by data. When we collect data, such as the number of petals on a flower, because I know you guys go out and do that often, or the age of students in a classroom, or items that are countable, we consider these data values to be discrete. Have you guys talked about discrete in science? Okay, so discrete, the main idea about discrete is that it is countable. Okay, you're counting specific things. Okay, now there is continuous data. And continuous data is where there is an infinite number of values between any two values within the data set. So usually continuous data values are measurements such as height, weight, volume, temperature, time, etc. Because there's always little pieces in between them. Okay, so measurements can't always be exact because there's so much in between it. Okay, there's infinite possibilities between the numbers 1 and 2. Okay, so this list of things, we are going to place a C or a D by the items to describe if they are continuous or discrete. Okay, in fact, I would like you to show me on your fingers as we go through. 1 will be continuous, 2 will be discrete. Okay, so I'm going to give you a minute to think about it. On number 1, the number of cows in a field. So 1 is continuous, 2 is discrete. Good. So D is correct. It is a discrete number because you can specifically count how many exactly there are in a field of cows if you wanted to. Pretty fun stuff. Okay. Distance it takes to stop a car. Good. It's C. So just remember that oftentimes measurements, if you're measuring something, it's going to be C. Okay? It's going to be continuous because there are a lot of different pieces between them. Okay, 3. Number of stars in the sky at night.
This is going to go with what everyone else is doing.
There's no way you can count all those.
You
Visible stars.
But
In the sky is one given time, you're just organizing.
You guys are overthinking.
okay, while it may be difficult, there is an exact number. Now, can more stars end up being created? I don't know all of that scientific stuff, but I think that there can. But there is a discrete amount. I know this is super exciting, but if we can keep our talking to a minimum. What? You can count specific stars, right? Okay. Body temperature. Good. It is continuous. It's a measurement, so there's a whole bunch of points in between even 2 degrees. Okay. Now, this one is tricky. Okay? It's telling you the digital reading of the amount of gas put into a gas tank. So think about this. So think about when you are looking at the digital reading. Is there an exact number that is being read? Okay, so this one is discrete. Now, while it's a measurement, the amount of gas, if they asked you the amount of gas that's being put in, that would be continuous. But digital reading is different because you're reading the specific value and there's a specific number. And so that is discrete. Okay. All right, moving on. Okay, the graphs for distribution look very similar to each other. If you look at the graph below, you will see the discrete data. So discrete is bars. There's a specific number that we're counting up. So remember how we'd have like X's or different things. When you see bars, that is discrete data. When you see the curve, that is your continuous data. Okay? This is oftentimes referred to as a bell curve. And that is continuous. Okay. Properties of normal distribution. Okay. Besides the fact that the curve is continuous, one property of normal distribution is that the area under the curve, or is the area under the curve, sorry. The area under the curve represents the probability of several events. In this section, we're going to explore some of the basic properties for normal distribution. Okay, one of the first things that you need to know about the curve, the total area under the curve is equal to 1, which is basically 100%. In statistics, there is the empirical rule, okay? Almost all the data will fall within 3 standard deviations of the mean. We found how to find standard deviations, right? So when they're saying 3 standard deviations of the mean, they're saying you can go out by that count 3 times in each direction, okay? And all the data should be within those 3 standard deviations. Okay, 68% of the data will be within 1 standard deviation. This is important. You need to remember these things. Okay, and we're going to write them. In fact, let's do this. 68% is 1 standard deviation. 95% is within 2 standard deviations. And 99.7% is within 3 standard deviations. So basically, here's what the empirical rule is saying. You take your mean, your average, and you add and subtract 1 standard deviation. Remember, the symbol means standard deviation. And when you do that, you will have 68% of the data. Okay, so for example, in 2010, the ACT average score for the nation was 21 points. The standard deviation that year was 5.2 points. That means that approximately 68% of the students that took the exam got between 15.8 and 26.2. How did they get the 15.8 and the 26.2? So what they mean by 1 standard deviation is you take 21 and you subtract 5.2. And so 1 standard deviation to the left is 15.8. 21 minus 5.2 gives you 15.8. And then 1 standard deviation to the right is where you take 21 and you add 5.2 to it to get the 26.2. So 68% are within 15.2 and 15.8 and 26.2. Okay, that means that out of over 1 million students that took the exam, 1 million-ish achieved a score within this range. Very interesting. I know. Okay, moving on. Okay, so if you add and subtract, and again, remember this stands for 2 standard deviations. That symbol means standard deviation. So if you add 2 standard deviations to your mean, that gives you your right, your high value, and if you subtract 2 standard deviations, that gives you your low left value. That will give you 95% of the data. So if you're looking here, this is your bell curve. If you go out 2 standard deviations from your mean, 95% of the data will be within there. Okay, and so it goes through. When you're doing 2 standard deviations, your low will now be 10.6 and your high will now be 31.4 because you were adding that, was it 5.2 twice? There are a lot of numbers in statistics. Okay, and then same thing with 3 standard deviations. This will give you 99.7% of the data, which is almost 100% of the data if you go out 3 standard deviations in each direction. Okay, now one thing to notice or note is that your empirical rule is only an approximation. Okay, it's a quick way to determine kind of like your range and what is normal. Okay, in reality, it's hard to obtain a true normal distribution. Okay, we use normal distribution to give us an idea of what the population or sample should look like or be. Okay, so now we are going to look at these graphs. So again, I had you write down some important information, and we're going to write it down again because it's going to help us here. So when you have 1 standard deviation, that gave you 68% of the data. 2 standard deviations gave you 95%, and 3 standard deviations gave you 99.7%. Now remember, when I'm saying 1 standard deviation, I'm going 1 from the mean to the right and 1 from the mean to the left. Okay? So it says here, on the x-axis, the amount of standard deviations, or z-scores, away from the mean. Okay, your mean is always your center. So like right here, that is your mean. That's your 0 mark. That's your starting point, and then going right and left. Okay? So remember how we talked about under the curve, there is 100%, correct? Okay, now they've shaded this portion right here. They want us to figure out, on the x-axis, the amount of standard deviation z-score away from the mean. What is this away from the mean? How much is shaded under here? What is the shaded area of the curve? So, we know that if we were to go out 1 standard deviation right here, this would be how much, what percent? 68%. Are you guys with me here? So I'm going to color this right now just to kind of hopefully give you guys more of a visual. So the yellow portion, that portion is 68%. Troy, are you following me here?
Yeah.
Okay. So in order to figure out how much just this shaded area is, I would start by going 100 minus 68. And what does that give me? 32. So 32 is these 2 sides. Do you guys agree?
Yeah.
So if I just want this one side, what would I do?
32.
Divide by 2. Good. So I'm going to go 32 divided by 2, which is 16. So that shaded portion is 16%.
Wait, did that say 100 minus 60?
Yes. So under your curve is always 100. I knew that this shaded portion is 68, so I took that out. So I knew that what's left were these 2 pieces. So these 2 pieces, like this piece and the other shaded piece, those equal 32, but only half of that is shaded. So that's why I took the 32 and divided by 2. So this is 16 and this is 16. And that makes my 100. Okay, let's go to number 2 and see if we can do this one here. So do you see on this one how it says minus 1 again? So that's 1 standard deviation. So we already talked about how 1 standard deviation to the right and 1 standard deviation to the left is how much? 68. So how do I get just this part? What do I do to 68? Divide it by 2. So this shaded portion right here is 34% of the data. So again, if you see how it goes to 1 and 1, I'm like, okay, I know that whole thing is 68, and all I'm doing is cutting that in half to find the shaded portion that's there. Okay? So now on number 3. Do you see on number 3 how it's going out to -2? So how far is 2 standard deviations in both directions? So if I'm like marking this and this is my +2, Okay, how much is in this shaded area? Good. That whole portion is 95%. So if I go 100 minus 95, what do I get? 5. And is 5 shaded? No, what would I need to do? Divide by 2. 5 divided by 2 makes 2.5% is shaded. Okay, do you think you guys can try number 4 on your own? Okay, I'm going to give you about, you actually have information on a different graph that we already found that would help you with this one. Look at number 1 and number 4. Can you guys compare those?
It's opposite of the. Oh, it's the same. Wait.
It's the same, just flip. So how could you find 4 very quickly?
What's 100 minus 16?
Yeah. 16. So do you see how 1 and 4 are opposite graphs?
Oh, shit.
And so this is 16.
84.
This one is 84%. You do 100 minus 16 and get 84%. No, because I know this portion is 16, and if that's the only portion that's not shaded, I do 100 minus 84. Now, if you didn't have this graph on here, I would know that one standard deviation is 68%, right? 68%. Then I have to add more. So I would take the leftover, the remaining from 64, or the remaining from 68 is 32, and 30 divided by 2 is 16. And 68 plus 16 gives me the 84. So that's the other way of working that one out.
Isn't 5 just 50%?
Well, these two portions are 32, so I have to divide in half. So this is 16 and this is 16. Okay, say that again.
Isn't 5 50%?
Yes. Can you guys see how much of the graph is shaded on number 5? 50%. You don't have to hopefully do any math. You can visually see that. Okay. This one's a little bit more tricky. Anybody know what to do on this one? Okay, let's see if we get the same one. This is how I did this. Okay, so this side of the graph, so if we go out 1 standard deviation, right? 1 standard deviation we know is 68, but what I'm going to do is, do you want to tell me what you did? Or do you get an answer?
Can you just take 100 minus 18.5?
Yeah. So yeah, so what Jacob, for those of you that can't hear him, he's like, okay, I know this little piece, which matches this little piece, is 2.5. Is this what you're saying? And then this piece I know matches with like this piece, which is 16. And so if you add those together, you get 18.5, and you do 100 minus 18.5, and you should get 81.5. Yeah, we're trying to find the black part. Now, I did this a little different. I didn't notice that at first. And so I know 1 standard deviation is 68. If I were to cut this in half, half of 68% is 34. So this piece here from 0 left is half of 68, right? Which is 34. So I took 68 divided by 2, which gave me 34. Okay, then I went to this side, and this side goes out 2 standard deviations. And I know 2 standard deviations is how much? 95, but it's only half of it. So I took 95 divided by 2. What happened? Okay. And that is 47.5. We then add those together, and I also still get 81.5% for my shaded area. So there's multiple ways of finding it.
It's like 95 divided
Yeah, because with 2 standard deviations, it's 95%, but I only have half of that. Okay, number 7. Anybody figure out this one? Okay, number 7. Anybody have an idea?
Well, you can't take half because it's not in the middle.
13.5%.
13.5% is correct. Do you want to explain how you did it, Joseph?
I'm just a natural genius and it came to division.
Okay, that's not a great answer.
It's a really long process. I just used like all the other pictures and like picked them apart to make that one. And it all up.
Okay, anybody do something more specific? Okay, Jacob?
I subtracted 2.5 out of 16 because 2.5 is a natural variable.
Okay, 2.5 from 16.
Because the 16
So we know that whole area is 16. So we took 2.5, the non.
Okay, so you knew this whole portion. I see that now. So since this whole left side from negative, from our 1 standard deviation right there is 16, and we found that that little piece was 2.5, 16 minus 2.5 is 13.5%. I did it differently. So I'm going to tell you guys my way. Was that the same way you did it too? Okay. So I know that 2 standard deviations, you know, from right here to right here. How much is half of the 2 standard deviations? We've done that division a lot. Half of 2 standard deviations. Okay, so I took 47.5 and I subtracted because this went out to 2 standard deviations, but it took out the 1 standard deviation. So how much was 1 standard deviation or half of 1 standard deviation? 34. Yeah. So I did 47.5 minus 34, which gave me the 13.5% as well. So do you see how I'm taking the whole 2 standard deviations and then I just subtracted the half of the 1 standard deviation to get that answer?
Are we done?
Okay, we're going to stop there.